Let's talk about supporting your VisualPlate project. If you start a new project, as I've done here, the first thing you will notice in the project status bar is that we have modeling errors. If I hover my mouse over the message, it's telling me we have no supports. So by default, no supports are placed on a model and you have to put them on yourselves. To place supports, we go to the Boundary and Support ribbon and look under the supports area here about in the middle of the ribbon. We have two types of supports that are used in VisualPlate. We have point supports. You can think of those, say, as columns supporting your plate or maybe bolt reactions. We also have line supports. You could think of line supports possibly as walls supporting a plate. So for placing point supports, the way we do is select it from the ribbon and then use our mouse and we point to where we want the point support. When I click on a location, the point support will be created, as you can see here. A point support is shown as a cross, and what we're showing with that cross is the two axes that we're supporting moments for and the vertical axis for the axial force. If I hit my escape key, I can get out of the draw mode and notice that when the support is not selected, it's smaller. So if I click on the support and look over in the inspector, we can see what we can do. We can change its position, so if the grid point was not accurately where you wanted it, you can move it. We have the ability to support the force in the Z direction, so that would be in and out of the plane of the plate. We can set moment restraints in both the moment X and Y directions, where X and Y are the global coordinate axes. By default, you can see they're fixed, which means it's a totally fixed support. If we take a look over here in the status bar, we see now we have analysis results. The analysis is done. So we're effectively supporting this whole plate at this one point, and you can think of it cantilevering off that point if you'd like. Let's change the moment restraint from fixed to free, for example. And when I do that, we can come over and see we now have modeling errors, and it's telling us we have inadequate supports. So now we have an axis about which this plate wants to spin, and with only one point support, it's certainly not stable. So we see that effect. In addition to making a support free, we can also make it a specified stiffness value. So for a moment support, which is what this is, we have rotational stiffness. If we look at the units for what we're showing here is a value that's in kip inches per degree. So if you want to specify a spring type support, you have the ability to do so by specifying the constant. So the ability to take a point support and making it fixed free or with a specified K is available in all directions. The other type of support we can apply is a line support. So if I go up to the ribbon and select Draw Line Supports, I can now drag my mouse and you'll see we have a rubber banding line. As soon as I let up on my mouse, we end up with a line drawn, and that line represents the line support. By default, it's selected so we can look over in the inspector and see what we can enter. For a line support, we can specify its starting and ending coordinates so we can position that line support more closely by changing these values. In addition, the support itself currently is fixed, which means along that line, the plate's not allowed to move in the Z or perpendicular direction, as well as it's not allowed to rotate about an axis that's parallel to that line. So we can have a moment along this line, and again, that moment would be about an axis parallel to the line. We also can change the support from fixed to pinned. Pinned means that it will not move in the Z direction, but it's totally free to rotate about an axis parallel to that line so that we have a truly linear pin support. Lastly, we can go to a spring support, and a spring support allows us to enter a spring stiffness for the moment about that axis parallel to the line. So here we can enter a spring stiffness. Notice the units. Their rotational stiffness, in this case kip inch per degree, per unit length, where the unit length is along the length of the line. So those are our options for supporting our plate.